Welcome to this M1 video on forces and acceleration. So if we have a non-zero resultant force that acts upon a particle, it will cause a particle to accelerate and accelerate in the direction of the resultant force. And this is basically Newton's second law of motion, which states that a force needed to accelerate a particle is equal to the product of the mass of the particle and the acceleration of the acceleration produced. So that is F equals ma. And this is what we're now going to be applying to our particles moving in a straight line. So previously we looked at forces as a vector and then the force diagrams. We'll use these in today's questions, okay, where we now start to bring in basically F equals ma. Okay, and this also applies to weight. So if I had an object that weighed 2 kilograms, its weight would be 2g newtons, okay, because its mass is 2. Yeah, it comes from F equals ma. Its mass is 2 and the acceleration is g, the acceleration due to gravity. Okay, so that would be the force of the weight. So if you will, weight is equal to mg. Now I think that's all we really need to talk about here. It's best to get into a couple of examples to explain further. Okay, starting off with a straightforward one. Find the magnitudes of the unknown forces x and y. So we've got an object here. It's accelerating to the right at 3 meters per second squared. We need to find x, we need to find y. This force going down is the weight, which is 6g newtons. Now we need to resolve basically in two directions. So if I resolve vertically first of all, okay, so resolving vertically, we're effectively using F equals ma, but we kind of can ignore it in this case because this is only accelerating to the right. There's no vertical motion, so there's no acceleration vertically. So, that's going to be equal. The resultant force, which is y minus 6g, is going to be equal to 0. So effectively, y equals 6g that way. Okay, newtons, or 6 times 9.8 is 58.8 newtons. So that is my y straight away. Now let's look at resolving horizontally. So now we're going to look at the horizontal ones. And again, we're using F equals ma. So it's accelerating to the right, which means that the force going to the right, which is x, is larger than the force going to the left, which is 5. So we've got x minus 5 is equal to the mass 6 times the acceleration, which is 3. So I've got x equals, now 6 times 3 is 18 plus my 5, so it's going to be 23 newtons. So x is 23 newtons and y is 58.8 newtons. And that there is a nice straightforward one. So now they're not necessarily equal to each other, okay, but you have to find the resultant force for F and then it'll be equal to mass times acceleration if it is accelerating. Remember, if it's going at a constant velocity, then there is no acceleration and the forces are equal to each other, which is what we had here. There's no acceleration, so the forces are equal to each other, so we could have jumped straight to y equals 6g in this case. Now, let's look at a more complicated problem. So I've got a body, a mass of 10 kilograms is pulled along a rough horizontal floor by a horizontal force of magnitude 30 against a constant frictional force of 6 newtons. Given that the body is initially at rest, find the acceleration of the body, the distance, the magnitude. Right, so first things first, let's just draw a sketch of what is happening. So I'll put my horizontal force, and then we've got a body of mass. So this is mass 10 kilograms. Okay, which means that it has a downward weight of 10g. And then upwards we have the normal reaction. Now it's being pulled along by a horizontal force of 30 newtons against a constant frictional force of 6 newtons. Okay. Given that it's initially at rest, find the acceleration of the body. So for this now, we're going to resolve horizontally. So we're using F equals ma, and the resultant force will be 30 minus 6. So we're assuming the acceleration is going to go this way to the right. And that's going to be equal to 10a. So 30 minus 6 is 24. Therefore, A is 2.4 meters per second squared. So that is part A done. Okay, now part B is the distance travelled in the first 5 seconds. So at this point now, we're going to abandon our forces because we've got the acceleration and it's a constant acceleration. That means we can use suvat. It was initially at rest, so u equals to 0, a equals 2.4, t equals 5 seconds, and s is what we want to find. So using those, we've got s equals ut plus half at squared. So that's 0 times t plus a half times 2.4 times 5 squared. And that is 30 meters. Okay, C, the magnitude of the normal reaction between the body and the table. So for this, we are resolving vertically. There's no acceleration vertically, so R is just going to equal that 10a, but if we do it, from the start, we've got R minus 10a equals 10 times 0. Sorry, not 10a, 10g. So R equals 10g newtons, or R equals 98 newtons. So I think you will agree with me that these questions, they're not too difficult at the moment, still easing you in. but hopefully they're starting to get a little bit more interesting. Now, if you like the video so far and you're yet to subscribe, go ahead, hit that subscribe button, hit that like button if you're finding it useful, and hit that join button if you want to and are able to help me out. Otherwise, let's look at the questions. So I've got 4 questions for you today. First one is just a little warm up, and then there's 3 past paper questions for you to have a go at. So pause now for questions 1 and 2. And pause now for questions 3 and 4. Okay, hopefully you are back having completed those 4 questions. Let me run through the answers with the workings. So, first question, nice and easy, just F equals ma. The resultant force is 100, the mass is 250, and A is the acceleration. So A is equal to 100 divided by 250, which is 0.4 meters per second squared. And that was the nice warm-up question. Let's have a look at number 2. So number 2, we have a lift, which I'll draw here, of mass 500 kilograms. Okay, it's lowered or raised by means of a metal cable attached to its top. Okay, and that will be T for tension. Now, in the lift, there are passengers whose total mass is 300 kilograms, so that's an additional 300 going downwards. The lift starts from rest and accelerates at a constant rate, reaching a speed of 3 meters per second after moving a distance of 5 meters. Find the acceleration of the lift. So it's at a constant rate. So here we're given enough information to use SUVAT. And a constant rate of acceleration means we can use SUVAT. So it starts at rest, so U equals 0. It reaches a speed of 3 meters per second after moving a distance of 5 meters. And we want to find A. So we want VU, A and S, so that's going to be V squared equals U squared plus 2AS. So that'll be 9, that's 0. This is going to be 2 times 5, so 10A. So A is 0.9 meters per second squared. Now, part B, the tension in the cable if the lift is moving vertically downwards. So if the lift is moving vertically downwards, okay, that means that if it's moving vertically downwards, and we're going to resolve vertically, and I put the arrow as down because that's like my positive direction. So we've got F equals ma. Now F is going to be 800G minus T is equal to 800 times 0.9. So 800G is 7840 minus, and 800 times 0.9 is 720, and that equals T. So T equals 7120 newtons. Okay, so that is part B. Now part C is the same, but this time the lift is moving vertically upwards. So part C, this time we're resolving upwards, and again it's F equals MA. So going upwards, we have the tension now is the main one, and the 800G is acting against it because it's moving upwards. And that's going to be 800 times 0.9. So it's T minus 7840 equals to 720. So 720 now plus 7840. So the tension in the rope is 8560 newtons. Okay, which makes sense. That is going to be more tension in the rope for it to accelerate upwards than coming downwards. It just makes kind of logical sense when you think it through. And that is the answer to number 2. Let's look at now number 3. Okay, so we've got a trolley of mass 50 kilograms is pulled from rest along a horizontal path by means of a horizontal rope attached to its front end. It accelerates at a constant rate, and after 2 seconds its speed is 1. As it moves, experience a resistance to motion of 20 newtons. We'll use T for tension, R, and then this is 50G. Okay, so what we've got to find here for part A is the acceleration of the trolley. So it's accelerating to the right in my drawing, but it starts at rest. So U equals 0. It accelerates at a constant rate, which is what we want to find. Its time after 2 seconds, V is 1. So V equals U plus AT. That's what we're using. So 1 equals 0 plus 2A. So A is going to be equal to a half, or 0.5 meters per second squared there. Now we need to find the tension in the ropes, so we want to resolve horizontally, and that is F equals MA. F is T minus 20 equals 50 times 0.5. So T equals, so 50 times a half is 25, plus the 20 is 45 newtons. So nice, easy part B. Now let's look at the final question, question 4. So we've got a van of mass 400 kilograms moving along a horizontal road. Yeah, so 400 kg. So normal reaction and 400 G. With a speed of 16 meters per second when the engine cuts out. Okay, so there's no forward thrust when that engine cuts out. The van comes to rest without the brakes being applied. In a model of the scenario, it is assumed that the van is subject to a resistance force which has constant magnitude of 200 newtons. Okay, so find how long it takes the van to stop. So assume this direction as the positive. So we're going to resolve, to the right. F equals ma. Now, the engine cuts out, so it doesn't have any force pulling it forwards anymore. So there's nothing there, like 0. And then it's still got 200 pulling it backwards. Times 400A. So A is minus 200 divided by 400, so minus 0.5. Which makes sense that it is minus because we are slowing down. Okay, so that is, my first step. Now, my second step is to put down what I know. So V equals 0. I know U is 16. A is minus 0.5. And we need to find how long it takes. So we need T. So V equals U plus AT. So carrying on up here, we've got V is 0, 16 plus minus 0.5 times T. So a half T equals 16, T equals 32 seconds. And that was all for A. Now let's look at B. How far the van travels before it stops. So still the same, but this time we're finding S. So U is 16, V is 0, A is minus 0.5, and we want to find S. So V squared equals U squared plus 2AS. So 0 equals 16 squared. Minus 2 times A is 1. So it's just going to be minus S. So S equals 16 squared, which is 256 meters. Now, part C is comment on the suitability of the modelling assumption. So it said in the scenario is assumed that the van is subject to a resistive force which has constant magnitude of 200 newtons. So a resistance force of like the van travelling is never going to have a constant magnitude, because that resistive force is made up of like air resistance, friction, and maybe other things mechanically, like basic, but like other types of friction. So the air resistance, well, air resistance is greater the faster you go. So as the van starts slowing down, the air resistance stops having an effect. And in terms of like the resistance due to friction, that would be a constant force to a point, but then as the van does slow down, that friction then decreases. Because if you think about it logically, friction can't be a constant force, because once the van stopped, if that friction was a constant force, it would start pulling it backwards. And we know from practical things that that doesn't happen in real life. Okay, so friction has like a maximum force of which might be applied. Okay, and overcoming that friction leads to the movement. But once you start going less than the friction's maximum force, it would just, it would also decrease. So the comment on the suitability of the model, we can basically comment on either of those kind of things. And I think, you know, the air resistance is the easiest one to talk about. So air resistance is unlikely to be a constant magnitude, as it usually depends upon speed. Okay, obviously it depends on other things, but in terms of like in this scenario, the speed of the van, the faster the speed, the more air resistance, the slower the speed, the less air resistance. So, you know, it won't have a constant resistive force. And there you have it for this video. So hopefully you managed to answer these 4 questions nicely. You can go ahead and try a few more from your book. You can use things like ChatGPT, said that right, to create more questions for you to have a go at. Otherwise, unless you're watching this the day it releases, there will be a video at the end of this to click onto to go into the next video, which is motion in 2 directions.